students, friends, parents, families of students, anybody watching this, it's good to see you again. Back at it, third video in a row, and I think I fixed the problem that I was having with the formatting. It's me, Mr. Swearingen. Let's begin our final lesson for Unit 7. This is 7.5. We're going to be talking about radical exponents. To radicals and back. Haha, clever. First of all, we have 8 properties. We can go ahead and quickly, because we're pros, fill these in. Oof, my pen is not wanting to work here. We'll do it like this. Power of 0 becomes 1. When we see a negative exponent, we need to move it to the other side of the fraction, making the exponent positive. If we have 2 of the same bases, we can add the exponents together. Here, when we have an exponent and an exponent outside of the parentheses, we multiply. Same thing here. We just want to make sure we distribute that exponent to both, or all of our bases, I should say. And then this last property that we learned last class is that if we have the same base in the top and bottom of a fraction, we can subtract the 2 exponents to figure out where it will end up going. That's our review. Once again, we do want to have that locked in our brains for today. Before we get, well, I guess the first thing we want to do as we want to get into today's notes is look at this. We're going to start talking about radicals. Radical is this fancy symbol drawn like this. Typically what that means is if we have, what's the radical of 4? What's the, it's called the radical, or a lot of times we call it the square root. So what's the square root of 2? Oh, of 4? I'm getting ahead of myself. It is 2. It's like the opposite of a power. The thing is, when we have a radical, like we see shown here, if we just look at this piece with the radical, we can have a base, we can have an exponent number, and then we can have this radical number out in front. Let me actually change that to a more distinguished color. Maybe this. So there's 3 different places we can put numbers or variables. The goal for today is that you will be able to see the patterns, because we can write it with the radical symbol, or we can just write it as a fraction exponent. See how right now this whole thing, m over n, it's a fraction, but that whole fraction is the exponent. That's what we're talking about today. When we have fractions like this, we can call fractions rational. That's why we call today rational exponents. It's because the exponents are fractions. So let's take a peek at this. When converting a rational exponent into a radical, maybe I'll zoom out so we can kind of see. Okay, and let me remember the order that I have it set up in. Yes, the denominator of the rational exponent becomes the root number. The numerator of the rational exponent stays with the base. I'm getting hunched over here. Eye contact is key. Oh, there's our bell. If we don't see an exponent with a base, it's always a 1. That's just a throwback reminder. So, I'll color code these first ones. I'll kind of keep it zoomed out just so we can see our example up here. Well, how's this going to work? There we go. Example 1, we have x to the exponent of 2 over 3. Well, let's just go ahead and start by writing the base. We can just write the base with the top number as the exponent. So see, I just wrote 2x to the power of 2. The only other thing we need to do here is put this symbol around it and put a 3 over here. According to my colors, I should make this 3 this, what would you call that? It's like a salmon-y, pinkish, orangey color. I think it's easiest to just write the base, take the top number of that fraction, 4, and then put the denominator outside. So I'll go ahead and color code here as well. I hope these are good for colorblind. Same thing, start by writing the base. Here our base is 2. What should I put? So maybe I'll put these blanks here, and you tell me what numbers should I fill in there. Ha ha ha. The blue will be 1. The orange will be 2. If we have an exponent of 1, we can just rewrite it with a base by itself. So the square root of 2 would be our simplified answer. Finally, example 4, go ahead, do this one on your own. Take a couple seconds. I'll take a drink. Pause if you need more time. I'm explaining. Well, I'll just give you the answer here. 6 to the power of 2, all with the root of 3. We call this, so here I should probably explain. When I talked about this word, the root is the number outside of the radical. So if this was a root 4, we call that special number the root number. So we've just learned how to take an exponent with a fraction, turn it into a radical. Now let's do the opposite way.
Hey.
Hello. I'm finishing up a video, so you get to be...
Oh, great. I'm so sorry. Did I ruin it?
No.
Okay.
No, you get to add to it.
Oh, great. Okay.
The other way, though, the other way of going backwards, when converting a radical into a rational exponent, oh gosh, let me make sure I keep this straight. The root becomes the denominator, the Oh, well, of course I'm getting mixed up with my own writing. Let's start by saying the root of the radical becomes the denominator of the rational exponent, and the exponent attached to the base, there we go, becomes the numerator. Oh, your sandwich is right over there. It's a lunch break, just for all of those people watching this. If you don't see a root number on the outside, it's just 1. Oh, sorry. If you don't see a root number on the outside, it's just 2. That's right? In a radical, if there's no number, it's 2. So we're just going in the opposite direction. We keep the base the same. A stays A. Well, let me be consistent with my color coding. Whatever exponent we have here, m, that will end up going in the top of our fraction, or our rational exponent. And then the root number n, that just goes into the denominator. So these examples, I'll do the first 1 or 2 right now. We write the base. Base is 5. This 2, should it go in the top or bottom, the numerator or denominator of this exponent? Hopefully you're thinking the top. That 3 would then, of course, go into the denominator. Good job. Example 6, this is where we have an invisible root. So see here, well, let me color code this correctly. Consistency is key. See here in blue, there's no number there. If there's no number, we see an invisible 2. So when we write this example, it's actually going to be W 3 over 2. Go ahead, look at these last 2 examples. Pause, work on them. I'm going to take a drink of Dr. Pepper, and then I'll talk about them. Okay, hopefully you paused and you're ready to learn or check your answers. Here I keep the same base. This 4 goes in the numerator, and the 3 goes in the denominator of our rational exponent. If you did that, brilliant. Example 8. It's very interesting because there's a lot of hidden stuff. Here we don't see an exponent with the 5, and we also don't see a root number. Well, let's remember, if our base doesn't have an exponent, we can just write in a 1. If the root doesn't have an exponent, we can write in a 2. If you were able to piece together those hidden pieces, that would then tell you that the rational exponent would be 5 to the 1/2 exponent. There you go. That is 7.5. We are done with notes for this unit. Let me know thoughts, feelings, questions, concerns. Have a great day.